Somewhere in Sweden, a building is filled with machine, not machine that makes car, not machine that make steel, machine that make intelligence. And five of Sweden's biggest company, the one that makes your medicine, your phone network, and their fighter jet, all of them are putting their money to build it. The question is why? Why does a country need its own factory just to build AI? Let's find out. And the thing nobody tells you about AI, training an AI model is not clever. It is brutal, it is complex, and it takes a lot of time to get done. The computer is doing one boring thing over and over, multiplying numbers in a grid, billions of times, then billions more, then trillions. And if you tried this on your laptop in front of you, a modern frontier model will take centuries to get completed. Maybe in that time we all will get die. Still it won't be completed. So engineers did the only thing you can do with an impossible job. They split it. One worker, for example, can build a house in 5 years. And similarly, 1,000 workers can build this in a month. Same job, cut into pieces, done at more faster rate. That is the concept of supercomputer. Not one big brain, thousands of small ones forced to cooperate for a particular task. So here it gets more interesting because this is the part where most people also get wrong. We have supercomputers for decades, but it was like used for weather forecasting, nuclear simulation, astrophysics. And those machines are obsessed with precision. They use 64-bit numbers because if you are predicting a hurricane, a rounding error in the 16th decimal place can move the storm 100 kilometers. AI supercomputers threw that away. They run on 16-bit numbers, sometimes 8-bit, deliberately because they have sloppy mathematics. Why? Because a neural network doesn't need exact. It needs approximately, right? A trillion times the model learns from a statistical pattern and the pattern survives rounding errors. And here's the payoff. Cut the precision in half and you roughly double your speed and half the memory consumption. So it is not a supercomputer or smart supercomputer. It is an average supercomputer pointed at a job where being dumb and fast beats the smart and slow. Now we can compare with surgical robot versus bulldozer. Both are powerful, but they have completely different jobs. Okay, so we split the job across 10,000 chips. Okay, and the hardest problem in the entire field, because the chips are not working on a separate thing. In this task, they are working on a same model. Every chip processes its slice of data, calculates how the model should change, and then every chip has to tell every other chip what it learned, and they all have to agree before it gets to the next step begin. Well, in engineering, we call gradient synchronization or all reduce. 10,000 chips, stopping, talking, agreeing, continuing thousands of time an hour, which means the slowest chip set the speed of all 10,000, and if the network between them is even slightly too slow, the billion-dollar supercomputer will get off nowhere. This is why this system use exotic interconnects and will link inside a rack, InfiniBand between them, moving data faster than most people's internet by a factor of 1,000. And in an AI supercomputer, the chips get the headlines, but the network is the machine. We have to understand one more thing. Once you solve the math and the networking, you hit the wall. That has nothing to do with computing, because there is another problem, that is heat and electricity. For example, pack 10,000 of chip into a room and you have built a furnace. Air cannot carry that heat away fast enough anymore, so the nervous system pipe liquid coolant directly across the chip. And the power draw of a large AI facility is measured not in kilowatt, but in megawatts, the scale of a small town. Which is why these things get built where the grid is strong and the climate is cold. Which is why they built in Sweden. In May 2025, I remember Nvidia CEO Jensen Huang stood in a southern Sweden next to Marcus Wallenberg, one of the most powerful industrial families in Europe. And the announcement was a consortium, AstraZeneca, Ericsson, Saab, and SEB, and also Wallenberg Investment. Together, they are building the largest enterprise AI supercomputer in the country, running Nvidia's Grace Blackwell GB300 system, operated by a new company called Spherical AI. But look at why. The AstraZeneca wants to design drugs, Ericsson wants to optimize networks, Saab builds defense system. Now ask yourself, do you want your national defense AI trained on a rented server in any another country, under another government laws? That is the word driving all of this. Sovereign means sovereign AI means the computer is on your soil, under your law, holding your data. France is doing, Germany, the Netherlands, it's happening across Europe right now. For 30 years, countries competed over soil, over oil, chips, and shipping lanes. Now they are competing over compute. So let's put the whole thing back together, that what we have learned from this video today. Starting with, training an AI is a job too big for one machine. So we split it across thousands. Those chips do deliberately imprecise math because fast and rough beats slow and perfect. They are wired together with networks so fast that the wires, not the chips, define the machine. It runs hot enough to need liquid cooling and hungry enough to need its own powers infrastructure. And that's why supercomputer is not just a bigger computer. Every single design decides the maths, the wiring, the cooling, the location. So in the part that I find genuinely remarkable, we spent 70 years making computers more precise. Now we are building something that could think. We had to make them less precise but much faster and make them work together. So the lesson in that somewhere, what we can learn from today, what we can learn from this video, these machines are built in Sweden, but they will not stay in Sweden. A medicine that will help to design medicines treats a patient in Nairobi, a climate model built there once a farmer in Bangladesh. That's how knowledge has always worked. It leaks, it is spread, it refuses to stay where it was born. So the real question is not which country builds the biggest machine, it's what we point it at. And that's decided by the people, by engineers who stood the heat and the wiring, by scientists who asked a better question. So if you are young and you are watching this, study, but don't study to get hired. Study like you are building the capability to change something. Study like the next generation has to live on earth. You leave them because they do. We are not short of machine. We are short of people who grow up enough to aim them well. Learn the hard things, aim them at something that matters. So, at last, if you understood and if you love this science, I will see you in the next one. Thanks for watching.